Yeah, in the yesterday session, just I was discussing about what is big data, why Hadoop drawbacks with current databases, Hadoop and Spark advantages, Hadoop and Spark job market, right? Yeah. Currently, we have got a databases, right, for OLTP, online transactional processing, and we have got specialized databases like Teradata, Netezza, Vertica for data warehouse purposes, which are used for analytical processing, right? Yes. But either databases or specialized databases cannot support unlimited or huge data, right? So as a solution that for all the storage level and processing level problems, right, we have got a framework called Hadoop. So generally Hadoop is meant for two things. Hadoop is meant for first storage. Yes. Hadoop is meant for processing. It is meant for storage and processing. For storage, Hadoop doesn't use any database, right? Because databases has got some drawbacks as I was briefing about. Yes, storage. So it is going with a special kind of file system called Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce. Or we go for Hadoop, or what is that, Spark, right? Yes. So processing, MapReduce or Spark. For storage, HDFS, right? Hadoop distributed file system. So Hadoop can perform both storage and processing. Any technology performs either storage or processing, but Hadoop performs both storage and processing. You may ask why databases can't be used? Why databases can't be used for storing Hadoop data? Drawback with current databases. And before that, as I was saying that Hadoop is meant for batch application. See, one thing what you need to understand, Hadoop is not for online applications. Hadoop is not for request response. Hadoop is not for client server. Hadoop, okay, Hadoop is for batch applications. Batch applications means millions and trillions of records, right? Processing millions and trillions of storing and processing, right? Batch. Hadoop is for batch applications. For one record or one transaction, right? Hadoop is not required. If you observe, right, there are two types of applications. Two types of applications, right? Yes. One is online application and batch application. Batch application. Online application, user interactive. What do you mean by online user interactive application? User interactive application. Here user gives the input, right? Yes. Here user gives the input. Yes. Here the user gives the input. Example of online application, right? Yes. Booking a movie ticket. Yes. Booking a movie ticket. Making a online transaction, right? Yes. Making a online transaction, right? Yes. Yes. Batch application. Batch application. User non-interactive application. User non-interactive application, right? Yes. User non-interactive applications. Here, user is nowhere required. Here, user is nowhere required. Example of batch application. Credit card statement. For millions of customers, right? For millions of customers. Credit card statement generation for millions of customers. Yes. Mobile statement, mobile statement generation. For millions of customers, right? Yes. For example, if I give an example for batch application, for example, if you are booking a railway ticket, right? Your waiting status, PNR status is 200. After 1 hour, it is 170. By today night, it is 120. Tomorrow morning, it is 70. Tomorrow evening, you got confirmed, right? Means it is here user not giving any input here. It is a background application which runs in the background, right? Okay. Most of the financial applications are batch applications. Most of the financial applications are batch. Yes, 1 second. Yes, observe here. Online and batch application. Hadoop is for only batch applications, right? Yes. And if you talk about why databases are not used for storing Hadoop's data, what are the drawbacks? Means limited storage we see in databases. Most of the databases, no parallel processing. If volume increases, speed decreases, right? If and I just given with an example, right? I've just showed with an example. If you observe query to query, if you observe this query 1, 2, and 3, yeah, I want sessions to be interactive, right? Yes. Try to respond which query executes faster among these 3. Yes. Total amount from sales 1, sales 2, sales 3. Sales 1 has got 10 records, sales 2 has got 1 lakh, sales 3 has got 1 crore. Total amount of 10 records, right? Yes. Total amount of 10 records, right? This query executes faster as compared with the other ones, right? Yes. Yes. So query to query, as volume increasing, speed decreasing, right? Complexity increasing, speed decreasing. Observe here. To sum of amount from sales 1, average amount from sales 1, standard deviation of amount from sales 1, right? So average, see, if you see which query executes faster means again the first query, right? Because average amount is a 2-step process. First sum to be calculated, next average to be calculated, right? Yes. Standard deviation of amount, right? So a lot of internal processing required. So as compared with this first and second query, third query is going to take more time. And the major drawback with databases, they can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? So before I go with Hadoop advantages, just I'll brief you, right? Hadoop, what do you mean by Hadoop cluster? Group of CPUs. Group of CPUs means nodes, we say. Group of CPUs, nodes connected in a network. Connected in a network, right? Yes. Group of CPU nodes connected in a network. There are two types of nodes. There are two types of nodes. Master node and slave node. Master node and slave node. In Hadoop, data stored by the slaves and data processed by the slaves. Then what master node does, right? So everything done by the slave node only. Data is stored by the slaves. Data is processed by the slaves, right? Observe this diagram, right? Yes. For example, I said Hadoop follows master and slave, single master and multiple slaves, right? Yes. Single master and multiple slaves. Slave 1, slave 2, so on up to slave n, right? This is the master node. These are the slave nodes. In database, data is stored in the form of tables. In database, data is stored in the form of tables. In Hadoop, data is stored in the form of files. f1.txt files, f1.txt, right? So this, for example, each slave 1 TB of capacity, its storage capacity 1 TB, assume, right? But this f1.txt 2 TB, right? Assume the size is 2 TB. Can it fit into any of the slave? It cannot fit into any of the slaves, right? Slave 1, slave 2, if we got 100 slaves also, it cannot be stored in any of the slaves, right? So in Hadoop, data is going to be divided into parts. Two advantages you are going to see here. If you are dividing the data or file into multiple blocks, multiple parts, two advantages we see, right? And you are storing across the slaves. You are storing across the slaves. So here 2 TB file can't be stored, cannot be accommodated by any slave. But if it is divided into smaller parts, stored across multiple slaves, data is distributed across multiple slaves and data is processed by multiple slaves parallelly. Think that a 10 lakh records in this, 10 lakh records is stored in this, 10 lakh in this way, every slave storing some lakhs of records. So all the slaves are executed parallel, all the slaves are executed parallelly, right? They are going to execute all the tasks parallelly. Parallel processing, you are going to see very high speed, because Hadoop has got high speed because of this parallel processing. And secondly, Hadoop, how Hadoop is able to store huge data means data is going to be split, distributed across multiple machines, multiple systems, right? And is processed parallelly, right? And here data is stored by the slaves, data is processed by the slaves. What are the master node responsibilities? So master nodes assigns tasks to the slaves. T1 task, T2 task, T3 task, executing this 10 lakh records, this 10 lakh. Okay, T1, T2, T3 task. Who is assigning? Master to slaves. And load balancing, balancing the load, right? Assigning equal tasks to each and every slave. Fault tolerance. Fault tolerance mechanism means while 3 tasks are executed by 3 slaves parallelly, suddenly if any one slave goes down, if any one slave goes down, then the task of that the task of that slave T2 is will be assigned to any of the other slaves. Who does this? Master. And before assigning the task to the slave, first it will check the health status. What is the health status of each and every slave before it assigns, right? Yes.
Sir, one clarification.
Yes.
How does it know the status of the slaves? Is there any agent installed on the slave that will provide a regular information to the
Yeah,
master?
see, actually, I was just giving an overview, right? Lot of things we need to discuss internally, right? Hadoop
Okay,
architecture,
okay, okay, sir.
storage architecture, processing architecture. Just to know the Hadoop advantages, just I'm briefing you. Hadoop doesn't follow client server. Master slave means you will have single master, multiple slaves. But lot of things we'll be discussing. Hadoop storage architecture, Hadoop processing architecture. Again, within this master and slave, we'll have job tracker, task trackers. Job tracker assigns the task tracker executes the task. More precise way, right? We'll be discussing in the Hadoop architecture, right? But as of now, Hadoop follows master slave architecture, single master and multiple slaves.
Sir, is it always a single master?
So, but from Hadoop 2 version onwards, there is a high availability concept was there. There is a new feature we got, right? High availability, HA. High availability means multiple nodes we can have. Multiple, right? Even for example, if one slave goes, we have got another slave, but from Hadoop 2 onwards, 2 version onwards, so there were some architectural changes. So I'll be discussing both, right? Both architectures so that you will know what was previously and what was now. So how was the architectural changes? We can go with the multiple nodes, name nodes, right? Internally, again, for storage, we got a name node, data node, secondary name node. Again, for processing, job tracker, task tracker. Okay. Again, in the latest architecture, we have got a lot of components like resource manager, application manager, resource scheduler, job history server, application master, node manager, container, right? We'll be discussing what each component and how the processing is going to happen step by step. Okay. Fine. So as of now, master node responsibilities, right? Yes. First one, task assignment. Load balancing, fault tolerance. Fault tolerance means when multiple slaves executing multiple tasks, suddenly if any slave goes down, then the task of that will need to be assigned to any of the other slave, right? And health monitoring, right? Yes. So you asked, right, one query. So heartbeat signals between the master and the slaves. If the signals are missing, then immediately it thinks that the particular slave is down. Immediately the task will be assigned to other slave. Okay, now just observe this Hadoop advantages, unlimited data storage. Unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited scalability. Horizontally unlimited scalability means observe.
Like we can add new systems.
Yes, yes. You are running with a less number of slaves. Slave 3. You are running with less number of slaves, but for example, your customers are increased, your data is increased, your business increased, your branches increased, data increased by 100 times, customer increased by 1000 times. You cannot go with the same number of slaves, right? So horizontally you will be increasing the slaves from 3 to 30. So horizontally increasing the slaves, horizontally unlimited number of slaves, horizontally unlimited number of slaves can be added. Okay, storage point of view, just observe here. You may ask, why only Hadoop can perform unlimited?
Slaves are the servers, or I mean, what exactly is master slave architecture? I mean, so master is any, I mean, server. I mean, and there are sub servers. I mean, how it is defined?
So,
Even
so just a group of CPUs, right? If you have got some 40 node cluster, one will behaves like the master, the other will be as the slaves. 39 will be the slaves. Means you will be configuring so master and multiple slaves. Uh, in all that master and slaves, you'll be having all the softwares be installed, but total monitoring, everything will be taken care by the master node. So okay, I'll just discuss more on this, right? Architectural part, storage and processing in that Hadoop architectural part, storage and processing. Observe here. You may ask why databases like Oracle, cannot support unlimited storage, why databases like Oracle cannot support unlimited storage. If you observe, right, even for databases, right, for example like Oracle, in real time we can go with multiple slaves. Databases, max limit on number of slaves, why databases like Oracle cannot support unlimited storage. So for example, Oracle, in real time it can go with the maximum 256 nodes CPUs, right? Once beyond that it cannot support, right? It cannot support further. Even for MySQL, right? If you talk about MySQL, you can go with 54 nodes, but MySQL Express can go with 256 nodes. SQL Server, right? SQL Server can go with 256. DB2 can go with 256. MySQL 254, MySQL Express 256 nodes, SQL Server 256, DB2 256, right? Yes. Any database, if you observe this, any of these databases, they are not supporting unlimited or huge data storage, right? But we have got some specialized databases like Teradata. They're used for data warehouse purpose. They can go with 512 nodes. Netija, they can go with 512 nodes. Teradata, Netija.
what is node? What are
Okay.
nodes?
Node in CPU, right? One system. 512 nodes are CPUs, right? So now currently Teradata and Netija going with 1024 slave systems, right? Slaves. Netija also, it's supporting nearly 1024 slaves for storing its data, right? but still we cannot say like Teradata or Netija, even though they are going with 1024, right? Still,
Big multinational companies. So they can also increase the nodes if it is a hardware cost is there. So they can also increase and they can become a, I mean, Hadoop company like, I mean, something
yeah,
like that. Why they are not doing it? I mean, why the specialized company like, I mean, I don't know whether Teradata is a company or not, or other these are the companies or
so now, okay, previously if we talk about this Informatica, or if we talk about the ETL technologies, right? Previously, they were using databases, right? But now when Hadoop came, right? Even Hadoop is given as a plugin for this Informatica. And if you talk about the 10th version, so for supporting huge data, right? So there is no limitation on Hadoop, right? How many number of slaves you can have. So here there is no limitation. So here there is no limitation. There is no limitation on number of nodes that Hadoop can have, right? That Hadoop can have. Horizontally unlimited scalability. The main feature what we see in Hadoop, horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. So when Yahoo first time implemented Hadoop, right? When Yahoo implemented Hadoop, it went with 4,000 slaves, right? For storing its data. Currently it is going with 12,000 slaves. Yes, Facebook, right? When first time implemented Hadoop, right? It went with 8,000 slaves, right? When Facebook first time implemented Hadoop, it went with 8,000 slaves. Currently it is running with 42,000 slaves, right? 42,000 slaves, right, for storing its data. So there is no limit on the number of slaves that Hadoop can have. It can go with any number of slaves, right? Horizontally unlimited scalability. Can add or we can remove the slaves as per the requirement, right? Yes. So here if you observe, and the processing point of view also, Hadoop advantages, horizontally unlimited scalability, and one more, very high speed processing. Very high speed processing because of parallel processing. Why? Because of what? Parallel processing. Can handle all varieties of data. So very high speed processing because of parallel processing, right? If you talk like the processing point of view, Yahoo has taken a table of 100 TB to test the speed of various databases, right? Consisting of 1024 columns. Task was sorting based on 16 columns. What was the time taken by different databases, right? Oracle has taken 3.5 days to process. MySQL like 6 days. Teradata has just taken 4.5 hours. Netija has taken 3 hours, but Hadoop just 3.4 minutes, right? Latest version has taken just 1.2 minutes. That's the speed of Hadoop. So it is proven in the market. Storage point of view with unlimited, right? Data storage and processing wise, very high speed, right? Yes. So if you see previously what all that ETL kinds of projects, all those are migrating towards Hadoop and Spark environment, right? Spark has got still very high speed, right? Because of this, everything storage and processing happens within the memory level, RAM level in memory, right? Yes. So and can handle all varieties of data. So as part of this course, we'll be discussing that handling structured, unstructured, and semi-structured kind of data. Open source. Hadoop and Spark is an open source, right? No licensing required. Cost cutting, right? Commodity hardware, very high configured systems. No, Hadoop can run on any software, any systems, right? Yes. So as part of this course, right, what are the Hadoop ecosystem components and Spark components, right? What I'm going to discuss, Hadoop ecosystem components. Hadoop ecosystem components, right? So we have got some components for storage and for processing, right? For example, for storage, we have got HDFS, Hadoop distributed file system. This is for storage, right? We'll be discussing about these commands, how we are going to pull the data from local system to Hadoop distributed systems, and similarly vice versa, right? How to export the data. And MapReduce. MapReduce is a kind of a processing component, right, which was mostly used if we talk about in 2012, 13, 14, 15, right? MapReduce has got a great boom in the market. So, but as of now, it got outdated. MapReduce, when we see Spark, right? Yes. So just I'm going to brief you about this. What is that MapReduce, mapper and reducer phases? How this processing is going to happen. So, but I'll be concentrating more on this, the techno that is mostly used, the techno that is the components which are mostly used, right, in the industry. And even the technologies, the components, other things also I'll be just briefing you about, but more concentration will be on this. So now Apache Pig. Apache Pig, it is also a processing component. It is also a processing component. Here we have got a language called Pig Latin. Pig Latin is the language. Use 1 second. Yes. Apache Pig for processing, we use a language called Pig Latin language. It is a simple scripting language, right? So this Pig Latin, if you write 100 lines of Java code, I can write the same task in Pig with 6 lines, right? That is what the easiness of Pig. It's a simple scripting language, and the important component of Hadoop Apache Hive, right? It is a kind of data warehouse kind of environment in Hadoop framework, where we are going to create a tables, internal, external tables, where we are going to make the data structured, create tables and querying, right? Performing querying, right? And also like some performance tuning mechanism, like partitioning, static partitioning, multi-column partitioning, dynamic partitioning, bucketing, indexing, combination of partitioning, bucketing, partitioning, indexing, combination of bucketing, indexing, combination of partitioning, bucketing, indexing, right? And working with different types of data, right? Working with the URL data, weblog data, working with XML data, working with JSON data, right? Working with UDTFs, right? Yes, user defined functions. So it's a kind of a data warehouse kind of environment. Here we use a language called HQL, which is similar to SQL, right? Yes. But only it cannot perform update and delete operations. Remaining all it can perform, right? HQL, similar to SQL only. And one more important component like scoop for important this scoop full form, right? SQL plus Hadoop. It's for SQL and Hadoop. The first two characters of SQ and last three characters, right? The first two characters and last three characters. It performs what? Scoop. It's for import and export operations. You are going to pull the data from different data sources from different databases, right? So SQL plus Hadoop, right? For import or export operations. Yes. Next we have what? NoSQL databases. NoSQL databases also, right? So it's for random access. How to perform sequential access? But for random access, you can go for NoSQL. And one more thing, it's a schemaless behavior. Means if we talk about SQL, record to record, same number of fields need to be maintained, right? From first record to last record. But in the case of NoSQL, record to record, different number of fields can be maintained. Okay. Record to record, number of fields can be maintained means my first record with 3 fields, second record with 5 fields, third record with 7 fields, last record with 10 fields, right? Record to record, different number of fields. But in the case of SQL, first record to last record, same number of fields need to be maintained. So as part of this course, I'm going to discuss the NoSQL database, HBase. HBase is the Hadoop database, right? HBase is HBase works only for the Hadoop environment, not for other environments, right? We have got many NoSQL databases: Cassandra, MongoDB, this HBase, CouchDB, React, Peanut, Neo4j, right? So among all these, Cassandra, MongoDB, HBase are the most famous, right? Apart from this, Yarn, yet another resource negotiator, Yarn and Yarn architecture. Zookeeper, right? It's the name itself saying, right? It's controls and coordinates all the Hadoop components, right? So it's for connection establishments, other things, right? The Zookeeper will be invoked. Apart from this, I'm also going to provide you the knowledge on Flume Kafka. Going to give knowledge on Flume Kafka, right? For stream, okay, Control Z. Flume Kafka for advanced streaming and for advanced streaming and messaging also. It is a streamer and messenger, streaming and messaging. Messaging nothing but establishing the connection between different distributed applications. Streaming, what do you mean by streaming data? Data which keeps on incrementing, data which keeps on generating. Such kind of data we call it as streaming data. So we capture that by using Flume Kafka and we'll dump into Hadoop and we'll process by using many processing components, right? Okay. Apart from this one, the important component Spark. So before I go with Spark, I'll be discussing first SCALA programming language. Next, like Spark Core programming, Spark SQL programming, such like the concept of data frames, Spark SQL and Spark streaming, micro batching. Yeah, like Spark Code, Spark SQL, and Spark Streaming. So I'll just provide you the entire knowledge of SCALA before I go with Spark. So more concentration on Spark. Out of this 70 or 75 hours, right? Mostly like 45 hours I'll be spending on Spark. Remaining like I'll be giving important components of Hadoop. Mostly I'll be concentrating with HIU, concentration on Scoop, NoSQL HBase, and the file system, right? And Yarn. And okay, yes. So this is what I will be discussing in brief. So it goes for 2.5 months, right? This 2.5 months course, and you'll be getting the recorded videos on daily basis. Clear notes you'll be getting. All right. Software also I'll be providing to your Google Drives. Videos also you'll be getting to Google Drives. Notes also to your Google Drives, right? Yes. Yeah. So tomorrow also you can attend the session to see more on this, right? Everyone, you can attend the session same time using the same link, right? To see more on this. Yes. Any queries you got, anyone, right?
Yeah, hello.
Yes.
So is there any new batch for morning session?
Morning, as of now, no.
No, okay. Okay.
Yes.
Sir, does it include a Hadoop administration also?
So mostly my concentration will be on development side, but wherever we configuration, how to install, how to configure different components, that everything I'll be discussing.
Okay, sir. And known issues related to Hadoop need to discuss, like what are the existing issues, how to troubleshoot that we discussed.
Yes, yes, everything I'll be discussing, right? If you are getting any errors, those things, right? How to rectify them. Yes.
Thank you.
Yeah, so tomorrow also you can attend the session same time using the same link, right? Yes. So if I'm done with your queries, right, I'll continue the session tomorrow same time. Fine. So
Thank you, sir.
yes.